Hello everyone, this is Dr. Fryer. Today's February 28th, 2025, and this is a recap of the third problem that we worked today in AP Computer Science class, getting ready for our algorithms quiz or test, which is coming up next week, and this is going to be the traveling salesperson, and we're doing this two ways, through the nearest neighbor algorithm and with the cheapest link algorithm. So again, if you want to do this on Notability, I'll include the link to this in the description of the YouTube, but you can take this slideshow, you can open it up in Notability, and then you'll have it here. So here we go, traveling salesman problem. Let's do nearest neighbor first. I don't know if I can, let me move that over, great. So here's the idea. We, in this case, have 5 different cities, and the goal is going to be to visit each city and try to minimize the time and the cost and therefore the distance that we're going to be traveling. In a nearest neighbor algorithm problem, you're always going to be told your starting location. So we are starting with London. This means that we are not only going to start with London, we're also going to end with London as well. And so that's important to keep in mind. So the first thing that we do is we take a look at, I've got to look, let's use a highlighter, I guess. I'm going to look across the London column here and see what my closest city is. And my closest city, starting in London, is going to be going either to Birmingham or Bristol. I can choose either one. Now, because these are both 120, it really doesn't matter. Either way can work. This is an approximation, and I think I'll go ahead and choose Birmingham. So my first leg is going to be London to Birmingham, and that's going to be 120 miles, okay? I'm going to end up adding all of these up. So I have now been to Birmingham. So the question is, now that I'm in Birmingham, I'm going to also look across that table. In fact, can I undo that? Do a different color. Let's highlight it in green. Here we go. Look across at Birmingham, and now, what is my nearest neighbor, the shortest distance that I need to travel to get to the closest city? And I can see it's 85. It's actually going to be Bristol, okay? So now my second leg is going to be Birmingham to Bristol, and that's going to be 85, okay? So I've been to Bristol. Now I need to take a look at where my next closest city is going to be from Bristol. So I'm going to look across Bristol, knowing that I've already been to Birmingham, I've been to London, so it's either Liverpool or Manchester. So if I look at Bristol to Manchester, that's 160. If I look at Bristol to Liverpool, that's 135. 135 is less than 160, so that's the nearest neighbor. So that's going to be my next leg. It's going to be Bristol to Liverpool, and that's going to be 135. And so now I only have one of my cities left. I'll have to go back to London, but it's going to be Manchester. And so if I'm going from Liverpool to Manchester, I can look across and see that's really close. That's going to be 35, okay? Let me make sure I'm not getting my things messed up here. All right, and then my last step, this is important, is to go back to my point of origin, which was London. So I need to figure out Manchester to London, and so I can look across, do another color, I'll do orange. So I'm going to look across my Manchester line, and I'm trying to see where is London. Manchester to London is 200, and so these are the numbers that I'm going to add up. So I'm going to add up 120, 85, 135, 35, and 200, and all of those distances together are going to give me my answer. This could be a little bit different if I chose, instead of going to Birmingham first, going to Bristol, but it's going to be an approximate, and it's going to be close. Okay, so I'm doing my calculator, 135 plus 35 plus 200. I'm doing this separately on my calculator. Okay, so I came up with 575 kilometers. Let me make sure that's right. 120 plus 85 plus 135 plus 35 plus 200. Yep, 575 kilometers. Okay, so that's the answer. That is using the nearest neighbor algorithm, okay? Now, we are going to shift gears, and instead of using nearest neighbor algorithm, another way to try to optimize our path, excuse me, is to use what's called the cheapest link. Now, in this case, we're going to use a map, and this shows us the latitude and longitude of our different cities. And what we're going to try and do is we're going to attempt, and we're going to start with the shortest first, to draw a closed figure that is going to allow us to visit all 5 cities, but it's going to be optimized, all right? And so this is the algorithm or the strategy for cheapest link. The first thing you need to do is you need to list all of your weights in sequential order from lowest to highest. And if I look at my table here, these 10 numbers right here are my weights, they are my distances, and I can sort of work from lowest down, or I can work backwards. So the smallest number is 35 kilometers, and I'll go ahead and put that at the top. The largest number is 220, and I'll go ahead and put that at the bottom. So I'm going to have 10 of these in all, and I'm going to be listing these sequentially. Okay, so we did 35. We didn't do 220. We didn't do 200. We did 220. So what's next after 35? I have, it looks like 85 as my next one, 85 kilometers. And then I've got a 90 here. And then after 90, I've got a 100. And then it looks like I have 2 120s. And I've got a 135. And I've got a 160. And I have a 200. So that is all of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I have put all of my weights or all of my distances in sequential order, increasing order from smallest to largest. What I'm going to try to do now is draw my edges. I'm going to draw my lines, and I'll do this in blue. And the first one I'm going to start with is going to be 35. That is Liverpool to Manchester. Now I can come up here and look at 35, and I can see that's Liverpool, Manchester, okay? And so I'm going to go ahead and draw that line. That's my first edge, okay? I'm going to go to my next number, 85, and I can see that 85 is Bristol to Birmingham. So Bristol to Birmingham is this line right here, and those aren't connected, but that's okay. They don't have to be connected initially. What I don't want to do is create a closed figure prematurely before I have all 5 of my cities connected, okay? So let's look at the next one, 90. 90 is Manchester to Birmingham, right here, Manchester to Birmingham, and that's fine. I'm not creating a closed figure, so I can go ahead and use 90. But when I get to my next one, I've got to be careful. Here's my next one, and it's 100. And so 100 is Liverpool to Birmingham. Now, I'm going to do this in a different color, and I'm going to erase it. I'll do this one in green. Liverpool to Birmingham is going to be a no-no. And the reason I don't want to do that is because it creates a closed figure, okay? It would make this a closed figure, and I haven't added London yet. So I don't want to do that. I am going to skip that one because I want to create, it's like a circuit, a complete circuit that I can go either direction, visit all 5 of the cities, and this will be in an optimized path. Now, you can see that my next choice is 120, and again, there are 2 different choices, and I can choose either one. This is the first 120 is Birmingham, London, and I could also choose Bristol to London. Now let's look at Birmingham, London. Birmingham, London, I'll do this in another color again. is going to be a no-no because it's going to create a fork in my path, and I want this to be a complete circuit, a closed figure. And so I'm not going to go ahead and choose that Birmingham to London, okay? I'm not doing that one. But let's look at the other 120. It's Bristol to London. If I connect Bristol to London, I'll go back to my blue here, that one is going to be fine because then my last leg, and I'll do this in orange so you can see it a little bit more. My last leg here is going to be London to Liverpool, and I've got a complete closed figure, okay? I've got a circuit, and if you think about the way that circuits work, I have a closed figure, and this is all going to work here. So I am going to say yes to this 120. That is the Bristol to London. And then the only remaining one that I have in order to close my figure is going to be this, London to Liverpool, and that is my last one, 220. So I'm going to add up all of these numbers, and that's going to provide me with my answer for cheapest link. 35 plus 85 plus 90 plus 120 plus 220, okay? That sum is going to be my answer. So I'm going to do it on my calculator. 35 plus 85 plus 90 plus 120 plus 220 is going to be 550 kilometers. That is the answer. Now, notice that there's a discrepancy between answers. When I used nearest neighbor, I got 575, but that's fine. When I used cheapest link, I got 550. These algorithms estimate what the optimized path is going to be, and different algorithms are going to result in different estimates, and that's fine, and that's what we expect. So I hope that is helpful to you, and I wish you luck as we continue to review for the chapter or unit 11, the unit 10 algorithms test and quiz next week.